So, hello everybody. Here is Wolfgang Gensch and Lubos Pertl on the other side. I'm currently sitting in Regensburg, very close to Lubos, who is sitting in Prague. So we welcome everybody. Yeah, I'm sorry. Yeah, hi.
I just say hello. This is Lubos Pertl.
No, it's nice. That is our usual test for tone and slides. Yeah, welcome again, Lubos. This is already our second webinar together today, and we both want to welcome, good morning America, so to speak, and good afternoon Europe. Today, Lubos and I, we will present about OpenFOAM in the cloud, an easy guide to use OpenFOAM in the cloud with a real live demo, which comes in the middle of the webinar from Lubos Pertl from CFD support. Okay, so we welcome everybody cordially, and I think we are ready to move. Okay, so let's start. What do you expect from this webinar? So we very briefly explain who we are, mainly three partners in this context here, CFD support, which provides the OpenFOAM software and support and additional services. Then the EGI Cloud, which is a large, I would say huge cloud federation in Europe, with over 24 data centers and over 250 partner organizations around Europe. And today we are connected to CzechNet, which is the Czech Republic data center in Prague. And finally, UberCloud, we are bringing in the technology and the cloud service, which glues everything together. So the very first start is about our engineering major tools, which in addition to the software itself is about workstations, servers, cloud, and we will look briefly at the challenges and the benefits of each of them. And the next one is we present a little case study, one of our 194 engineering experiments in the cloud so far. And I will go into the detail a little bit later about this. Next one then is that Lubos then accesses OpenFOAM in the cloud in a live demonstration. And you will see with or at your fingertips how easy it is. So this is the live demo. So Lubos has selected an example about flow simulation around an airplane wing section. And then at the end of this webinar, it is your turn. So we talk about your application, and we can offer like 24 cores on any cloud resource for 24 hours. Okay, so let's briefly go into some details. Lubos, if I may, I can simply introduce you.
Yes, please.
Okay, sure. So this is all about CFD support. So Lubos and his team, they are sitting in Prague, and they are focusing on development and consulting for computational fluid dynamics with a specific focus on OpenFOAM, on the software, on the support, and additional development and services projects for our CFD community. And the products which I mentioned, one, so is OpenFOAM Inbox, which is very nice, it's free. However, it is not comparable with, not directly comparable with the standard, open source version, because it is packaged, it is tested, evaluated, benchmarked, and beautifully set up. And then there is this commercial turbo machinery CFD version, which is sitting on top of OpenFOAM, but very specialized for turbo machinery applications and kind of usable or easy to use for the engineers. And then Lubos and his team, they offer OpenFOAM training and support and development, as I already mentioned, and also the specific turbomachinery CFD package. Okay, then we have the EGI Cloud. I already mentioned that, so let me put some more information into the slide. So they have 23 cloud providers in 300 plus data centers. And they are continuously growing. So some impressive numbers which you see at the bottom of the slide. And today, as I have mentioned, here you see Chestnut in Prague is our data center which we have selected for this webinar. Finally, this is UberCloud. I already mentioned we started 4.5 years ago with so-called engineering cloud experiments, taking engineering applications together with the engineer, together with the service provider, and together with a cloud resource provider into the cloud. Watching carefully, the challenges and the benefits they get, and then writing a case study at the end. Every year we are publishing a case study compendium, which this year will be announced in Digital Engineering, one of our important magazines here in the community. And when you look regularly at it, I mean, you might even get now, because you joined the webinar as a courtesy, an invitation to download the 2016 compendium of case studies with about 20 case studies. Okay, so after we have learned a lot about the challenges and the benefits, and we have selected our technology, which I briefly mentioned later, it is all about software containers, where we have packaged CFD supports OpenFOAM software into, and the next step then, as I said here, was the containers. It is all about easy packaging, porting, access, use, and so on and so on. So this is a new and a novel technology which is already widely in use in the enterprise application space, and which we have taken 3 years ago into the high-performance computing CAE space. So currently there are a lot of software containers already for everything what CFD support produces, like the OpenFOAM, like the turbomachinery packages, and as you can see, also other software widely in use. And it's sitting on clouds from the EGI, which I have mentioned, but there are also other cloud providers. We are dealing with about 50 of them. And some examples are Advania in Iceland, Amazon's AWS, Microsoft's Azure, Bühl, Atos, Extreme Factory, CPU 24/7 in Potsdam here in Germany, and OpenCloud in California, for example. And we have very strong partners which support what we do, and vice versa. We support them, which is Microsoft's Azure Cloud, HPE with their private and public and hybrid cloud strategy, and Intel with their whole software stack in the cloud. Okay, so let's jump into engineers' major computing simulation tools, which is about workstations and servers mostly in the recent past, but lately we also see engineers moving to the cloud with parts of their workload. So we recommend everybody not to immediately consider to jump completely into the cloud and move every application and every simulation into the cloud, but usually a well-balanced workload, partially in-house, partially off-premise, so to speak, renting resources in the cloud for 1 day, for 1 week or so, depending on your project size, makes a lot more sense, and is, by the way, the most economical way to currently do it. Okay, so we did this experiment, these 194 experiments so far, because we learned a lot about the current behavior and preferences of the engineers. And one is what you also can see from the US Council of Competitiveness. They have published a report which says, although workstations are really great systems, sometimes they are limited namely limited by the compute power, which can be too slow when you have long-running jobs, not only overnight, but during several days, over weekends, and so on. And on the other hand, very often memory can be too small. And we know, a few million cells or finite elements can be nicely put into a workstation's memory. But when it comes to 10, 20, 50, or even 100 million cells, then this goes far beyond the capacity of a workstation's memory. And therefore, we are looking closer to servers. Servers provide more compute power and more memory. So basically, they solve these problems or the limitations which workstations have. They produce, therefore, higher quality designs and therefore also higher quality products with many more simulations, testing many more parameters, doing finer geometries, which increases at the end of the day your competitiveness in a global market. In addition, a very important one is with more and more simulations, you have the benefit, or you can discover potential failures in the early designs, which you can eliminate by simulations, by more simulations, because later on these failures can be very, very expensive when the product is already in the market. And yes, with the servers, you can shorten time to market drastically, because you can run, instead of one simulation at a time, you can run 10 simulations at a time with 10 different parameters, for example, or geometries or materials and so on. So that's a real benefit. But unfortunately, I personally cannot afford a server. It takes months to acquire one, to buy one, to select and, to get it through the management hierarchy to get to the final approval. Then it is not only the server cost, which might be a few $100,000 or even millions, but together with the server cost, there comes a high total cost of ownership for the 3 to 4 years the server is active. There are people you have to pay, there is software, there is training, there is space, energy cost, and so on. And it easily can get to up to a factor of 5 on average, in addition to, or 5 times the cost of the original server. And then there are complex high-performance computing software tools which you have to master, and you have to build an infrastructure around it. And then on the other hand, because of these rapid technology refresh cycles these days, I mean, Intel is coming up, for example, with 2 times a new generation of chips. So within 3 years, this on-premise server can relatively fast become outdated. And then very often you don't use them 100%, but there are days where you use them 95%, other days you are only using them 25%, depending on the projects you have, on the people, the number of people who use it. And therefore now we look towards the cloud. The cloud comes with all these benefits which a server has, because you just simply you have a server in the cloud, right? In addition, you have even more compute power. So you are not restricted by the number of nodes in your home server. That's usually as much as you can afford and might make sense on the average. But here you have a lot more computing power, and it is all on-demand, pay-per-use. So today, the most common model here is really renting a server of the size you want for the time you want. It is really like renting a car and driving it. As long as you rent it, you really own it, kind of, and you can do what you want. You don't have to share it with someone else, which usually is very common in the enterprise cloud space, where many virtual machines, many applications can sit on one server. Here in the high-performance computing community, you own your own server. so for the time you have rented it. And then you can scale resources dynamically, even up and down. You know, one day you use 24 cores, the other day you use 128 cores, and so on. So you can be very flexible with exactly, you know, adjusting everything to your actual needs. And finally, you have a choice. Depending on your different applications, you might use different resources, different cloud providers. One is coming with InfiniBand as an interconnection. The other one is just coming with Ethernet. And for different applications, very often different architectures are fitting best. And that can be reflected by using, respectively, different cloud providers. And the result is what we summarize under better, faster, cheaper. Which I just mentioned on the server side. And here in the cloud, it is really at your fingertip, which we want to demonstrate in a few minutes. So Lubos will demonstrate how easy these days it is to access any application in any cloud. But again, there are very quickly cloud challenges. Okay, cloud is a new paradigm, and there is a lot of you know, hype was around it. Not anymore. It is not anymore the question if should I do it or not, but very often what we see in the industry now is the question when should I move some of my workloads to the cloud? So there is a security and intellectual property issue. But again, I mean, I tend to say clouds today are like Fort Knox. Cloud providers spend a lot of money and hire great security specialists to basically secure their cloud environment, including the people, you know, and including the technology. So it is very comparable to what basically the big companies today have built up over the last 5 to 10 years. And so there is this traditional software licensing problem, which is usually, you know, you remember it is annual perpetual and can cost a lot of money. And cloud providers, software providers, they have hesitated for a long time and watched the cloud space because they were certainly, and with good rights, concerned about their business model. But in the last 2 years, we have seen many of the well-known software provider companies to move to the cloud as well, you know, as an additional short-term licensing model which they introduced, and we can go into detail a little bit later. Then this is data transfer. I mean, in our experiments already, we saw that engineers are moving back and forth something like, you know, 5, 10, 20 gigabytes easily. And but there are means today to avoid that. To either, you know, speed up the data transfer, or just do remote visualization, or simply send the data overnight back via FedEx, which about 10% of our engineering experiment people are doing in practice. Sounds funny, but is you know, very secure, very fast. Next morning, 9 o'clock, you come to the office and your data are here on a little storage medium. Then, you know, until recently, you need real cloud expertise, you know, to build your systems in the cloud, and then, you know, to set it up, to configure the software, to load your data, and all that stuff. Before, and it could take weeks until, you know, the first time you have set up everything, and then you are ready to go. But this has disappeared also, and we will go into that detail a little bit later. One important thing for engineers is, you know, engineers are very curious guys. They want to know everything, what happens with their application, with their systems, with their, you know, servers, etc. And in the cloud, you tend to lose control over your jobs, over your data, over your systems. Compared to your desktop, we call it server hugging in our community. You know, you love your server, you love your workstation. Obviously, I mean, for very good reasons. And I love my laptop here as well, because now I can talk to you. And I have full control over it. You will see that this novel technology of containers, they bring all the control back to you. So you own the container, it is your environment, and you can send back and forth things, and you control even down to the system level. You can see how many cores you have, how busy the cores are, and you get full control back to have a very good feeling about how your applications are set up and running. And if there are some failures, convergence problems, for example, over the time steps and iterations and so on. And this is already I mentioned, the first access to clouds is oft, and still today is oft cumbersome. Often you have to hand over your whole information. I mean, the application software, the data, and your specifics to the cloud provider. And the cloud provider is then selecting the resources either in-house or working with other partners. So the best way really is that the containers provide the complete control over your over your software, over your data, and whatever you do with it, and the tools. Okay, so very quickly, as I mentioned about these new software containers, which are already in the enterprise space for 5 years or so. So we have taken them, we have developed several layers of HPC features such that they are now very suitable for example, CAE applications like OpenFOAM in this context here. The containers are removing all these CAE cloud challenges which you see here, and I don't have the time to go into these details, but there is a little article on our website which is Workstations, servers, clouds, comparing apples to apples, and if you don't find it, please shoot me an email to wolfgang.gensch@ubercloud.com, and I will definitely send it to you. Okay, let's move on. A little case study before Lubos is demonstrating this same case study in the cloud. So we worked with a technology consultant in India for one of his customers. So this is Praveen, and the software provider in this case was Lubos, and his company CFD Support with the OpenFOAM software, and with service and support during installation and runtime, etc. Then the resource provider here was the EGI Cloud, which I briefly mentioned, Sai Holzinger, Giuseppe Rocca, and they selected a resource for us which is sitting in the Czech Republic. This is Chestnut, and we have been supported here by Boris Park from Chestnut. Thanks a lot to this team, and also to Hilal on our side, who supported the containerization of OpenFOAM and the service in the context of that one. Okay, let's run through that. So we have an airfoil, which is a section out of this piece of the wing of an airplane. This is NACA 4412. You will see that in the live demo very soon. And there's a very nice quote from Praveen that basically says, this is a great environment. And so after a few time steps and iterations, which Lubos in live will perform, you see results through ParaView then, like pressure and lift and a few other interesting physical and geometrical results. So here Praveen just had a workstation with 8 cores on his desk, and he tried a FET node which he was able to get from Chestnut in Prague then, and did some benchmarks with it. And you see the nice scaling here, and he also increased the number of cells up to 2 million, and as you can see, all the runs seem to scale nicely across all the different number of cores. So the conclusion is that this environment is really like an engineer wants it. It is identical to your workstation. You will see that again from Lubos' demonstration. What he does is really live. So it's always for me to getting a bit nervous in that context. And so the idea is really to build an environment which is identical to your workstation. So nothing new to learn. It all goes through a browser, and from there you work the same way, identically, as you are used to work on your home desktop workstation. It is minimal effort to get to the cloud, and you will see that in a second. And then what we have seen is, for example, our average experiments in the very beginning, they took 3 months. From A to Z up to writing the case study, because we had to convince all the software providers and the cloud providers, etc., to work with us to do a free experiment, set it up, etc. And that was 3 months in the very beginning. Then more and more it was weeks. And recently with the container technology, it was just 1 or 2 days. So, and no failure anymore. Every experiment went through smoothly. So now we are approaching the live interactive demo. As I mentioned in the very beginning, there is an UberCloud marketplace, and as you can see, there is also under the software provider stores, we call that here internally the engineer's shopping mall. And you see, you can access different stores in the shopping mall, and one of them is CFD support. And when you go into the store, you see a lot of products which are ideally already made for you and ready to go. So you click on it, and as soon as you paid, you see prices $49, $99, etc. So then you get a welcome email and saying, "Hello, Lubos, very welcome. This is your link to the cloud, and this is your login." And then you click on the link, you copy paste your login information, and then you are there. And this is this kind of welcome email which you get, which I just explained. And I think here we go. So this is the copy paste of your login information, and I would now hand over the control of this webinar to Lubos. Please give me
yes.
1 second. Now I declare you moderator. Let me see.
Okay.
So now you should have the control for,
Okay.
Oh yeah, there's already your screen.
Okay.
Thank you very much, Lubos.
Okay, thank you, Wolfgang. Thank you very much for your presentation. Hello, everybody. So this is Lubos Pirkl from CFD Support. I would like to briefly show you an example of a CFD simulation on a cloud. The beauty of this cloud solution is you always work from a web browser. No matter which operation system you have, no matter what computer you sit at, you do not need any of your own resources. You only need the web browser. So I guess I share you my screen now. Actually, yeah. So I believe you can see right now what I can see. So here's the example for today. The example we want to show you is the well-known NACA 4412, which is a typical airfoil which was measured in NASA and also computed in NASA. So the case is well known. The case description can be found on the NASA website. The aim of this test case is to evaluate the pressure coefficient and the trailing edge separation. The test case is created. It can be downloaded on our website, on the CFD support website, so anybody can come and download the test case and run it in standard OpenFOAM version. Perhaps this is the time to show you how to connect to a cloud and to perform a simulation on it. So the only thing you need is the web browser, which is I'm in my Mozilla Firefox right now, and what I'm gonna do, I will put the link which I need from the provider, right? So I will put down, I will input the link, which is EGI, the UberCloud.net, and I also need a password. And now I'm connected to a cloud. As you can see, the desktop looks exactly or very the same as any other desktop on your computer. So now I am through the web browser. I am in the cloud. I am in the CentOS Linux operation system, and I can do here everything what I can do in my normal personal computer at home. So I have a web browser here. I have all the resources which I have on a normal computer. So I'm gonna show you how easy it is to simulate this NACA Airfoil example. So I'm opening a new terminal window, and I'm going to navigate to my run directory in my OpenFOAM version, and I'm gonna use the Midnight Commander, which is a great tool because you can switch between the file manager and between the command line, which is exactly what I need. This workflow is what I'm used to. That this is my message. This is what I want to show you. At home, I'm used to use the command line and switch all the time to the file manager, and from there I can manage my files. Okay, so this test case is already preset, which means everything is done. I will just quickly show you how to run it, how the workflow looks like, and then we can move to in our presentation and to your questions. So okay, the basic settings is in the file which is called allrun.sh. I will open it. Yeah, I will just check the basic settings. Yeah. By the way, this test case was originally created for our OpenFOAM training for the turbulence course, where we test different settings and the influence on the results of various turbulence models. So we are going to use K omega SST for processors. Yeah, the smallest mesh. So what I'm gonna do, I'm gonna run the solver directly, which I can do by running the script, which is the shell script, and perhaps I will forward the standard output to yeah, to some file, and I will run it in the background. And now the case is running. I can see the processors are in use. So yeah, I can quickly take a look. I have 4 processors in this cloud session, and all of them are running on 100%. So my case is running. I can do some more tests. I can, for example, take a look how the velocity is developing in certain points around the airfoil. So I will take a look on my script, which is in GNU-plot, which is called probes u.gp, and here you can see how the instantaneous velocity values are developing, and also their averages. So I can see it's obviously it's developing and it's converging quite well. The instantaneous values are meeting the averaged values, so we are about in the middle of our simulation. I think we are going to run until 5,000 iterations. So now it's simulating. Everything seems to be really okay. Yeah, I can immediately watch the results, or I can perhaps wait till the simulation is finished, and then I will check the results in ParaView and also in the plot of GNU-plot. Okay, so simulation is running. I can do whatever I can do in my standard computer. So yeah, couple of seconds to go, and simulation is finished. So we are running on 4 processors. We're quite simple case. It's like 4,000 cells. Okay, so if the simulation is finished, what you can see now is the pressure coefficient distribution along the blade, along the NACA 4412 blade. You can see also the comparison with NASA experiment and NASA's part Almara's simulation. The agreement is quite good. We have very rough mesh. We can, if we would refine the mesh, we would meet the measurement almost perfectly. What I would like to show you now is the visual post-processing, which is done in ParaView, especially with the command parafoam. You can pretty easily, again, the workflow is very the same as on your personal computer. You can see this is the NACA airfoil. We can, for example, take a look at the velocity magnitude. It's typical for this test case. There's the angle of attack about 13 degrees. Also the pressure is typical, and yeah, the post processing is very the same as on your computer. There are also the integral values plotted somewhere, and graphs in GNUplot, and also some visual post processing in ParaView. Yep. So, well, Wolfgang, I think I made my point. Actually, my point is, I will repeat it. Nowadays, you can work on a cloud in the exactly same way as you are used to work on your personal computer. That's my point. And the question is whether to continue with the live demo, or do we move back to the webinar. So
thank you very much, Lubos.
What do you think?
We will have very soon a Q&A session, so everybody can go to their webinar panel and put in some questions. I would say I think I have 2 or 3 more slides, and if you hand over the control back to me.
Okay, I will. So I will make you a presenter, which I did right now.
So please tell me if you see my screen.
Yes, we can. So everything is in normal. You can go ahead.
Okay. So let me just get it up again. So this was the last slide you have seen from my screen. It was about this very nice live interactive demo from Lubos, and about the aerodynamic study of airflow around an airflow in the EGI Cloud. So yes, this already looks like the last slide. It is now about you. So it is your turn. You might want to consider OpenFOAM cloud training and cloud usage in an very early stage, obviously. So you can run your own OpenFOAM application in the cloud, and we all help you with that. It will be very easy. So for example, 24 hours on a 24 core node in the cloud, for example with Intel Xeon, 56 gigabyte of RAM, 605 gigabyte of disk. So this is one of the standard HPC, high performance computing nodes, which we have access to. then OpenFOAM support from CFD support is included. So whatever is about CFD, this is Lubos and his team, which then accompanies you, and you can send a little request to their support staff, and they will help you immediately. And it is, for example, for this example, it is can be paid by credit card or by invoice, depending on the situation you have. And the special offer for all webinar participants is that you can have a free, and usually our experience is this is just in the order of 1 hour then, a free professional cloud introduction, training and support during your 24-hour use for all webinar participants. So, and I think so, let's see, yeah, this is a big thank you to everybody. We know your time is precious, and we very much hope that you could gain good insight into what's going on, you know, in, you know, like an advanced technology, advanced services in the cloud these days. The last 4 years have changed a lot of things, and you see it is now very straightforward to use cloud resources for your specific application. Okay, so now that we have done that, let's check the questions box here, and I see there are already, oh yeah, how nice. So let's see. Lubos, have you access to the questions as well?
I have, yeah. So I'm ready to serve.
Yeah, this is nice. The first one is funny. It says, "Good afternoon from Brazil." Okay, how nice.
Okay.
Good afternoon back. So let's scroll down. How is the post-processing in the web-based platform? I mean, to create videos for big models using the ParaView. I saw that performance is low to manipulate the model. Okay, there are several answers. So yeah, I hand it over to you, and yeah, please.
Actually, yeah, it's really, yeah, no big deal. Well, the how is the post-processing in the web? It's exactly the same. There is no difference. So the post-processing is exactly the same as as it is on your computer. And also videos for big model. Yeah, it depends which resource you take, but they're really the same. Regarding the ParaView performance, well, I can go back. Okay, I will make myself a presenter if you don't mind, and yeah, I will make disappear these questions. Yeah. So well, I'm in ParaView now. Well, I would say, yeah, I would say the performance is, I think it's acceptable. You know, I work with CFD models like 15 years, and this is what you see. Maybe I see it quite fluently. I think it's as good as on personal computer. Maybe the webinar do some I don't know, some you know, compression of the video. So maybe you don't see what I see. It would be a matter of tests. But I think it's quite fluent. It's quite smooth. Yeah, no big deal. Also, it depends on your connection to the internet, right? But yeah, the workflow is really the same. Ordinary, typical engineer would, I bet, ordinary engineer would not recognize the difference at all.
Okay, so there is a follow-up question about, and certainly, I mean, when you look closer, there I can see a very minor delay, and so there is a question: how can we speed up the transmission of the data? Okay, this is a very good question, and it relates to what Lubos already said. So Lubos kind of interactive working with the data is kind of relatively easy because he has a short connection to his cloud provider. When cloud providers are used, resources of cloud provider which are farther away, like a few countries distance or even across continents, obviously then simply because of the internet and also depending on the size of the model. I mean, is it a few 100,000 cells? Is it a few million cells or so, even 10, 20? Then you see, you really recognize the delay of this data transfer. But we are working with partners here like NICE software in Italy. NICE has a very nice product which is DCV, which enables instant and HD transfer of the pixels of the pictures, right? So like 6 million pixels per picture and 30 pictures pictures per second is produced by simply speeding up the data transfer by GPUs. So the master node, the head node of your cluster, which you have perhaps built in the cloud, or which we have built for you, for example. So on the master node, then you have a GPU which accelerates the data transfer up into HD quality. So you won't see any little difference anymore. And NICE software, so the company, they are in many conferences presenting, at exhibitions, etc. So when you have a chance, you get to one of those conferences and you see NICE there, you can have a very nice live demo. I might even consider that we do another webinar in the next couple of months together with NICE to really demonstrate this. Because, we get this question very often, and this is one of the real challenges which you face, but as I mentioned previously, which you certainly can avoid. By the way, there is another partner we are working with. This is vCollab, and their software, so it is V and Collab like in collaboration, and their software does filtering. So if you don't need all the data, like 10 gigabytes or so back, because you are in the middle of still improving, modifying, and optimizing your model, then this software allows you to filter your data. So, for example, if you look only at the pressure of the profile which you see here on Lubos' screen, then you simply request the pressure data, and which is, maybe 100 megabyte, and not even. And this certainly is transferred, instantly. Or you want velocity, temperature, energy, whatever. So you select by clicking, at the mask. You select this data, and it is shipped over to you immediately. And you can really analyze the specific data which you got in-house at your desk. So these are a few tools which are all built into the container, which then you can choose. Okay.
Okay.
So
Wolfgang,
yes,
I have a question on you. What do you see now? Do you see my questions window, or you see the Airfoil?
No. This is only the operators panel is only visible for you and me.
Okay. So because I have put it out of my Okay. So the next question I will take it. It's part of the question is how is the Linux environment set up on the cloud? Can I compile my own code and or own custom OpenFOAM functions? It's exactly the same. I just repeat. It's exactly the same as on your computer. So there's the OpenFOAM installation somewhere in the container, which is, yeah, it's called OpenFOAM Inbox. It's OpenFOAM Inbox 16.06, and it's completely full version. So you can bring your code, you can compile it, and you can operate as usual. Yeah. By the way, there is a standard set of tools, so you can use, for example, Dropbox or any other client or service or application you are used to operate your files from your home to the cloud, right? So you can use FTP, you can use the Dropbox, you can use HTML, you can use all the services you are used to. Yeah. So it's very the same as on your personal computer.
Okay.
Yeah.
Great. Lubos, I take another one. Very simple. What is the difference between the cost in the cloud and the cost on the workstation? Okay, so this is So this is another great question. I would a little bit reformulate it because you want to compare apples with apples. So imagine you want to run your application on a 4-node 64-core server, just as an example, right? And then you want to compare it with the same environment in-house, on-premise. So what does it cost to operate a 4-node 64-core cluster in-house versus the same environment in the cloud? So here it is very important to start looking also at the utilization. So if you have a fully utilized system in-house, which is all the time, 24 hours, 7 days a week, etc., fully utilized, 100%, then your cost can come down to about, so what our calculations show, and we have another cost paper, the ubercloud.com/cost on our website, where you find some more details. The cost goes down to in the order of 10 cents per core per hour. So this is what you also can get today in the cloud, right? There are even cloud providers who have access to, very cheap energy. Those cloud providers who are sitting up in the north, for example, who have kind of a very easy cooling and very easy power supply, etc. For example, by hot springs coming out of the earth. So there are some of these out there now. Now quite a few data centers are moving over, to the northern part of Europe and America. Interesting enough. So then the cost can even go down lower to 8, 7, even 6 cents. I have seen around the globe in the meantime. As you see, then the cloud service is even cheaper than what you can do in-house. However, now with your in-house environment, if you don't use it all the time 100%, say you use it on average just 50%, in a sudden you are twice as expensive as with a fully utilized system, and maybe 3 times as expensive as a cloud service. So the lower your degree of utilization of your in-house system is, the better is the benefit from the cloud side. So that is there is some discussion in this paper which I mentioned, which you can look closer at. Okay, thank you. Do we have another question? Currently, do you see one more, Lubos?
I think this is it.
I see. Yeah, I scroll down and up in our question box. It looks like this is it. And Lubos, are we ready to complete this?
I think so. I think, yeah.
Okay. Okay, and certainly I want to encourage everybody, if you have additional questions, just send them over to us. My email address is wolfgang.gensch@theubercloud.com. So then we will certainly, as fast as possible, answer your questions. Also, to all the participants, we will send the slides and the link to the recording to you within the next 2 or 3 days. And finally, for those in America, in the US, I wish you, and we wish you, sorry, Lubos included, absolutely. Yeah. I'm not sure if you are aware of that, but these guys have Thanksgiving coming in 2 days. So
today, okay.
Yeah. I just came back from California, so everybody is hectically preparing Thanksgiving. So we wish everybody in the US especially a happy Thanksgiving, and enjoy your family event there. Okay, thank you so much, and bye-bye.
Okay, bye-bye. Yeah, thanks for your time. Bye-bye.